A new study suggests large marine species were wiped out in a supernova-triggered mass extinction event some 2.6 million years ago at the dawn of the Pleistocene. The supernova, located just 150 million light-years away, would have appeared as an oddly bright light in the prehistoric sky, lingering for many weeks, maybe even a few months. But within a few hundred years, long after the strange light in the sky had dwindled, a tsunami of cosmic energy from that same shattering stellar explosion could have reached our planet and pummeled the atmosphere, triggering mass extinctions of large ocean animals, including shark species the size of a school bus. A new study reported in the journal Astrobiology examines the effects of such a supernova and possibly more than one on large ocean species. The study's lead author, Professor Adrian Malott from the University of Kansas, says these supernovae could have affected the Earth at some time or another. What makes this event special is that this time Malott and colleagues have found evidence of nearby events at a specific time, and they were able to determine just how far away they were. And so they could actually compute how that would have affected the Earth and then compare it to what they know about what happened at that time. Malott says recent papers revealing ancient seabed deposits of iron-60 isotopes provided the slam-dunk evidence for the timing and distance of the supernovae. As far back as the mid-1990s, scientists knew that iron-60 was a telltale sign for supernovae. That's because there's no other way for it to get to Earth other than from supernovae. You see, iron-60 is radioactive, and so were it formed with the Earth, it would be long gone by now. Therefore, any deposits found today must have rained down on the Earth later, and the most likely source would have been nearby supernova events. The authors say there's still some debate about whether there was only one single nearby supernova or a whole chain of them. Malott favours a combination of the two, a big chain of supernovae with one that was unusually powerful and close. See, if you look at the iron-60 residue, there's a huge spike 2.6 million years ago, but there's also an excess scattered back nearly 10 million years. Other evidence for a whole series of supernovae events is found in the very architecture of the local universe, especially a structure in the interstellar medium known as the local bubble. It's a 300 light-year wide region of very hot, very low-density gas. Nearly all the gas clouds have been swept out of this area, and our solar system is right on its edge. The best way to manufacture a bubble like this in interstellar space is by having a whole bunch of supernovae blowing it bigger and bigger. And this seems to fit well with the idea of a whole chain of supernovae going off one after the other. Previous calculations were based on the idea of a single supernova going off, and the energy from that single event then sweeping over the Earth. At the local bubble, and the cosmic rays kind of bounce off the sides of the bubble, resulting in a cosmic ray bath lasting maybe 10,000 to 100,000 years. But by using a series of supernovae going off one after the other, then these things would feed more and more cosmic rays into the local bubble for literally millions of years. Now, whether or not there was just one supernova or a whole series of them, the supernova energy that spread layers of iron-60 all over the Earth would have caused penetrating particles known as muons, heavy versions of electrons, to literally shower the planet, resulting in increased rates of cancer and mutations, especially for larger animals. That's because muons are several hundred times more massive than electrons and therefore very penetrating. Even normally, there's lots of them passing through you right now. Nearly all of them pass through harmlessly. About 1/5 of your radiation dose comes from muons. But when this wave of cosmic rays hit, you could multiply those muons by several hundred. Still, only a small fraction of them would interact in any way, but when that number is so large and their energy so high, you'll still get increased mutations and cancer. And that would have had serious biological consequences. The authors estimate cancer rates would have gone up by about 50% for something the size of a human. And the thing is, the bigger you are, the worse it gets. So for something as big as an elephant or even bigger, say a whale, that dose would go way up. So a supernova 2.6 million years ago may well have been the cause for a marine megafaunal extinction thought to have happened during the Phyllocene-Pleistocene boundary, where some 36% of the genera were estimated to have become extinct. According to the authors, the damage from the muons would have extended down several hundred meters into ocean waters, but of course, the greater the depth, the less severe. So, high mass and consequently high energy muons which can reach deeper into the oceans would have been the more relevant agent for biological damage as depth increases. Malott says one of those extinctions 2.6 million years ago would have involved a shark known as Megalodon, a close relative of today's Carcharodon carcharias, the great white, also known as the white pointer or simply white death. Great whites are known to grow to well over 7 metres in length. That's the size of Bruce, the mechanical special effects shark used in the movie Jaws. But textbooks show white point is getting much bigger than that, with the record being a colossal 12 metres or 36 feet. But Carcharodon carcharias' ancient cousin, Carcharodon megalodon, grew much bigger than that, to around 18 metres or 60 feet.
You're going to need a bigger boat.
So, Malott says imagine the great white shark in Jaws, which was enormous, but make it 3 times bigger to the size of Megalodon. And although the largest predator of its day, Megalodon suddenly disappeared about 2.6 million years ago, the time of the supernova event. Malott speculates this may have had something to do with these muons from exploding stars. He says basically the bigger the creature is, the bigger the increase in radiation would have been. And evidence of a supernova or series of them is another puzzle piece to help clarify the possible reasons for the Phyllocene-Pleistocene boundary extinction. Malott says there really hasn't been a good explanation for the marine megafaunal extinction until now. And so this could be it.